Hello everybody, we're having a look at determining the equation of a linear graph today, and this is a really fascinating area, so let's get started. What we're actually going to do is we're going to go from information about what's on the graph, or even looking at the graph as a visual, to working backwards to finding what its equation is, and it's a bit of a detective act and it's great fun. So we know that y equals mx plus c, don't we? Now we're m, what's m, and what's c? Can you remember? Well, I'll tell you. That's the gradient, that's the y-intercept, okay? And then what we need to do is find both m and c in order to find the equation. That's pretty obvious, isn't it? Okay, so how do we find the gradient? How do we find the gradient? Well, we actually need two known points on the graph, okay, to find the gradient. And we label those points, or I recommend that you label those points point 1, point 1. It doesn't matter which one you label 1 and which one you label 2, but call them one of them point 1, that's x1 and y1 then. And then you label point 2, x2 and y2. And then we have a formula for the gradient. M is the gradient, it equals y2 minus y1 over x2 minus x1. Now, if you basically faithfully follow that procedure, where you assign a value of x2 and y2 to point 2, give them values, and do the same thing for point 1, you know these points, so you can easily read off their values. So you'll know what point x1 is, you'll know what the value of y1 is, you'll know what the value of x2 is, you'll know what the value of y2 is, and you use that formula. Now, before I go any further, yes, you can say y1 minus y2 over x1 minus x2. It makes no difference. It'll all come out in the wash, as my mum used to say, and it'll work. But you have to be consistent with if you put 2 and 1 here, you must put 2 and 1 here, and don't mix them up like going 1 and 2, really meaning 2 and 1. You'll mess it up if you do that. Okay, so that's the rise over the run, and there we go. See, look, this is x2 and y2 from point 2, and down here we've got x1 and y1 from point 1. Now, if you knew those values, you could easily substitute those in to get your m. That's what I'm saying. Did you get me? Yeah, it's pretty simple. Now, okay, let's do some examples and see how we go with this stuff. Now, we've got to find the equation of the straight line shown in that graph. All right, now come on, do what I said to do. This is a visual, so we're going to basically write that out as x comma y. It's the y-intercept, so it's 0, 6, yes? And we're going to call this one, that's the x-intercept, which was 3, so that's 3, 0, okay? Y is 0 here, and x is 0 here. You know that, don't you? I'm going to call that 1.2, and I'm going to call that 1.1. Okay, you can call them the other way around. I don't mind. It still works. That's x2 and y2 then, and therefore that's x1 and y1. So now, the next step is to assign a value of x2. x2 is 0, y2 is 6. Yeah? You get that? x1 is 3 and y1 is 0. Yes? Good. Now we can easily do this, this thing. No problem. We know that c is 6 because we've got the y-intercept anyway. Okay? Remember that? So all we've got to do is get the gradient, and we're laughing. So therefore m equals y2 minus y1 over x2 minus x1, which gets me that. Doesn't it? I think so. If you look at it, it certainly does. And that gets us that. Now that gets us minus 2. Alright? Minus 2. So if the equation of the graph is y equals mx plus c, we can just plug and play, guys, because we know m is minus 2, we know c is 6, and there she be. Okay, do you like it? It's easy as, really. Easy as. Now what's this? Find the equation of the straight line shown in the graph. Well, we've got 2 points there. I can see them. I can see them. Well, did you just say you could only see one? Well, yes, you can see one here, but look, what about this? This is 0, 0, because it's going through the origin, right? So that's what we're going to do. We're going to use that information. That's point 2, x2, y2, and that's point 1, and it's 0 and 0, and that's x1 and y1. So let's assign our values. x2 is 2, right? X before y, remember? And y2 is 1. Don't mix them up. They're like in the alphabet. X is before y. This one here, x is 0 and y is 0 because it's at the origin and both of them are 0. Okay, so now we can work out our gradient. We have to work out the equation of this straight line, do we? Yes, that's right. So therefore this, yes, did you notice that this equation has no y-intercept at all, okay? Because it goes through the origin. So therefore it has the form y equals mx, right? No c anywhere because c is 0, all right? You're with me, aren't you? Good. Therefore, we still need m though. We've got to get m. So what is m? Let's do our formula. There she be. M equals y2 minus y1 over x2 minus x1. Now it's plug and play now. It's so easy, guys. There it goes. Okay, y2 was 1, y1 was 0, x2 was 2, and x2 was 0, so you get that. It's a half, all right? We've done it now. We've got the answer. Therefore, y equals a half x. Happy? Good. What's this one? Okay, no visuals this time, just a couple of points. Well, look, it's just as easy. It's just a slightly different technique. We know that's our formula. That's what we've got to get. We've got to get m and c. Now, that's no problem, don't panic. Because to find m, we just assign one of those values as 0.1. I've assigned 0.1 as the first one that you see up there. And I'm going to assign, that's x1, y1, yes. Therefore, x1 is minus 2, y1 is 5. That's important to put that step in. If you're inclined to get mixed up, that's a very good idea. Just state it out as simply as that, right? Now, meanwhile, back at the ranch, 0.2 is 1 and minus 1. So that's it. So therefore, x2 is 1 and y2 is minus 1. So let's just go for our formula now, our gradient formula, plug and play. Today, hooray. So it's minus 1, minus 5. Now this is the bottom line, it's got a booby trap, look. This is 1 minus 2. Now, come on, you have to put minuses in a bracket. Otherwise you're going to get into big mess. What's 1 take away negative 2, guys? Yes, it's plus 2. 1 plus 2. That gets us a minus 6 over plus 3. And what does that get us? Minus 2. Alright, so that's our gradient. That's our gradient, minus 2. Now, okay, now you're thinking, well, yes, but that's alright about you, Wolfman. What are we going to do to get C? We don't know what C is, and they haven't given us a graph so that we can observe what C is. Fear not, my child. Look, this is what you do. This is what you do. You know the equation now. We've filled in one of the pieces in the jigsaw puzzle here. Y equals minus 2x plus c. And if we substitute one of these 2 points in, a known point in other words, where we know the x value and the y value, and we put those values, the x here and the y there, into this equation, then c becomes the only unknown, and it basically reveals itself to us. That's what we do. So I'm going to substitute this point here, minus 2 and 5. You can put the other one if you like. It won't make any difference at all. It'll still work out. So I'm going to put that in to find c. So therefore, there's the y value, there's the x value, and it looks like when we just clean that up a bit that 5 equals plus 4 plus c, so c would be 1. So there's the answer, guys. There's the answer. There is our equation. Happy? I think so. Right. Now we're on a roll. What's this one? This looks extremely easy. We've got a gradient of 2 and a y-intercept of minus 5. Are they serious? They've told us what the equation is, virtually. So therefore, that's the formula. M, C, and they told us the gradient was 2, and the y-intercept was minus 5, so you just plug it in. That's our formula. That's the answer. Yes, sirree. That's it. All right, one more to go, and then we will dismiss for the video for the evening, and you can go and do some practice. So what we're doing here, finding the equation of a straight line passing through the point 5 and minus 1. with a gradient of 3. I don't think this is a problem at all. We've already got m, haven't we? And we've got a known point to substitute into the equation to get c. Let me show you. Here's y equals mx plus c. Now, here comes, where's m is 3, no problem. So put that into the jigsaw, right? One piece already put into the jigsaw. This is the only piece missing. And we can plug this known point in here. This value of x is 5. This value of y is minus 1, into this point here, that'd be 5. That point there would be minus 1. And this little baby here can't hide from us anymore. There it is, yes. So there we go. Now, let's work this out. This looks like minus 1 equals 15 plus c, and a simple little bit of algebra to work out c. So what would you do to get c, guys? Yes, you would subtract 15 from both sides, wouldn't you? That gets us, yes, and that gets us minus 16 equals c, and it's all over bar the shouting. We've got it. There it is, and there's our answer. See how, pardon the pun, see how easy it is, see? And this is our summary, and I'm not going to go through all of that because it takes too much time, but I would like you to pause the video and to have a look at it, just review it, get it into your mind, and see if you understand it all. If you don't, then you better ask your teacher or somebody who knows, okay? And then you'll be able to go ahead, and all power to you, you will be able to conquer these questions with no problem at all. Alright, and you're a star of course, and you'll go far, providing you practice, and we'll see you next time.